Networks can be classified based on size, functionality, and usage. Here are some common types. Local Area Network, or LAN, is a small network covering a single building or office, like a home Wi-Fi network. A Wide Area Network, or WAN, covers large geographical areas, such as the Internet. A Metropolitan Area Network, or MAN, covers a city or large campus, like a city's public Wi-Fi network. A Personal Area Network, or PAN, is a very small network for personal use, such as Bluetooth devices connecting to a smartphone. A Storage Area Network, or SAN, is a high-speed network for data storage, like enterprise cloud storage networks. Protocols define rules for communication between devices in a network. Some key ones include Transmission Control Protocol Internet Protocol, or TCP/IP, which is the foundation of the Internet and manages data transfer reliability. Hypertext Transfer Protocol, or HTTP/HTTPS, is used for web browsing, with HTTPS adding security. File Transfer Protocol, or FTP, transfers files between devices. Simple Mail Transfer Protocol, or SMTP, is used for sending emails. Post Office Protocol, or POP3, and Internet Message Access Protocol, or IMAP, are used for retrieving emails. Domain Name System, or DNS, translates domain names like google.com to IP addresses. Dynamic Host Configuration Protocol, or DHCP, assigns IP addresses to devices automatically. Secure Shell, or SSH, provides secure remote login to network devices. A network protocol is a set of rules that determine how data is transmitted between different devices in the same network. It allows connected devices to communicate with each other regardless of any differences in their internal processes, structure, or design. Internet Protocol, IP, will discharge packets from the source host, and it will deliver to the destination host via IP address in the packet header. Network protocols are the usual procedures, rules, formal standards, and policies comprised of formats. It allows communication between more than one device connected to the network. Network protocols have to do end-to-end process of secure on-time and manage data or network communication. All requirements which combine process on network protocols so as to carry out the communication between routers, servers, computers, laptop, and other authorized network device. Here on network protocols might be installed and routers in both sender and receiver to ensure data or network communication, and apply to software and hardware nodes which communicate on a network. Types of networking protocols. Network communication protocols. It is the basic data communication protocol. It includes of HTTP and TCP/IP. Network security protocol. It confirms security over network communication and includes HTTPS, SFTP, and SSL. Network Management Protocol. It provides network governance and maintenance and include ICMP and SNMP. The Internet is a worldwide system of computer networks, a network of networks where the users at any one computer can get information from any other computer. The Internet is a network of global connections comprising private, public, business, academic, and government networks connected wired by guided, wireless, and fiber optic technologies. It was developed by the Advanced Research Projects Agency, ARPA, of the US government in 1969 and was first recognized as the ARPANET. The unique aim was to generate a network that would permit users of a research computer from one university to talk to research computers on other universities. The jargons Internet and World Wide Web are frequently used interchangeably, but they are not precisely the same. The Internet denotes the global communication system, including infrastructure and hardware, whereas the web is one of the services interconnected over the Internet. Intranet is a private network within an enterprise to share company data and computing resources between the employees. It may consist of many interlinked local area networks and includes connections through one or more gateway computers to outside Internet. Internet of Things refers to the digital interconnection of everyday objects such as home appliances, wearable devices, or automobiles with the Internet. The thing in IoT refers to objects that have been assigned an IP address and have the ability to collect and transfer data over a network without manual assistance or intervention. Extranet is a private network that uses Internet technology and the public telecommunication system to securely share business information with suppliers, vendors, partners, customers, or other businesses. The application of the Internet includes downloading programs and files, using social media, sending emails, engaging in e-banking, participating in audio and video conferencing, conducting e-commerce, sharing files, utilizing e-governance, browsing for information, searching the web addresses for access through search engines, chatting, and more. The application of the Internet involves sharing company policies, rules, and regulations, accessing the employee database, distributing circulars and office orders, accessing product and customer data, sharing information of common interest, launching personal or departmental homepages, submitting reports, and maintaining corporate telephone directories. The application of the extranet includes customer communications, online education and training, account status inquiries, inventory inquiries, online discussions, supply chain management, order status inquiries, warranty registration, claims, and distributor promotions. A mobile network or cellular network is made up of a large number of signal areas called cells. These cells join to form a large coverage area. Users can cross into different cells without losing their connection. Within each cell, there is a base station which sends and receives the mobile signals. A mobile device will connect to the nearest or least busy base station. The base stations are connected to a digital exchange where the communication is sent to other telephone or data networks. Cells will often be smaller in size in large towns as the number of users in the area is more. Communication over mobile networks is made up of voice, data, images, and text messages. Mobile networking assigns technology that supports voice and data network connectivity using radio transmission solutions. The common applications of mobile networks are mobile phones, tablets, and more. In the past, wireless communications largely used circuit switching to carry only voice over a network. But now both data and voice are being transmitted over both circuit switch networks and packet switch networks. The generations of mobile networks are as follows. First generation 1G in 1981 with the NMT launch, second generation 2G in 1991 with the GSM launch, second to third generation bridge 2.5 in 2000 with the GPRS launch, third generation 3G in 2003, fourth generation 4G in 2007 and fifth generation 5G in 2019 and beyond. First generation 1G 1981 NMT launch. During the initial periods, the mobile systems were based on analog transmission. NMT stands for Nordic Mobile Telephone Communication. They had a very low traffic density of 1 call per radio channel and a very poor voice quality, and they used unsure and unencrypted transmission, which leads to the spoofing of its identities. Second generation 2G 1991 GSM launch. Later the second generation of mobile systems were placed on digital transmission with GSM. GSM stands for Global System for Mobile Communication, which is the most popular standard used in the second generation, using 900 MHz and 1800 MHz for the frequency bands. GSM mobile systems grew digital transmission using SIM. SIM stands for Subscriber Identity Module Technology to authenticate a user for identification and billing purposes, and to encrypt the data to prevent listening without permission, known as eavesdropping. The transmission used TDMA. TDMA stands for Time Division Multiple Access, and CDMA stands for Code Division Multiple Access method to increase the amount of information transported on the network. Mobility is supported at Layer 2, which stops seamless roaming across assorted access networks and routing domains. This means that each operator must cover the entire area or have agreements in place to permit roaming. Second to third generations bridge, 2.5G, 2000 GPRS launch. GPRS was introduced here. This is the excess period of mobile networking development between 2G and 3G. GPRS stands for General Packet Radio Service. GPRS is a data service which enables mobile devices to send and receive messages, picture messages, and emails. It allows most popular operating speeds of up to 1/15th bit s, later reaching a maximum of 384 bit s by using EDGE. EDGE stands for Enhanced Data Rates for Global Evolution. GSM data transmission rates typically reached 9.6 bit s. Third generation, 3G, 2003. This generation of mobile system merges different mobile technology standards and uses higher frequency bands for transmission and code division multiple access to deliver data rates of up to 2 Mbps, supporting multimedia services, MMS, voice, video and data. European standard is UMTS, Universal Mobile Telecommunication Systems. Mobile phone systems continue to use digital transmission with SIM authentication for billing systems and for data encryption. Data transmission used a WCDMA. WCDMA stands for Wideband Code Division Multiple Access, a technique to obtain data rates between 384 bit s and 2048 bit s. Few 3G suppliers use for over-the-air network within MPLS multi-protocol label switching or IP for their backbone network. Mobility is still supported at Layer 2, and hence like 2G, it still prohibits seamless roaming beyond heterogeneous access networks and routing domains. The transmission were band frequencies between 1900 and 2200 MHz. All UMTS license holders at the UK holds a 20-year license with the condition that 80% population coverage is achieved by 31st December 2007. Fourth generation, 4G, 2007 4G is at the research stage. 4G was based on an ad hoc networking model where there was no need for a fixed infrastructure operation. Ad hoc networking requires global mobility features, e.g. mobile IP, and connectivity to a global IPv6 network to support an IP address for each mobile device. Logically roaming in assorted IP networks, for example, 802.11 WLAN, GPRS and UMTS, were possible with higher data rates from 2 Mbits to 10, 100 Mbits, offering reduced delays and new services. Mobile devices will not expect on a fixed infrastructure. They will require enhanced intelligence to self-configure in ad hoc networks and having a routing capabilities to route over a packet-switched network. Fifth generation, 5G, 2019 plus 5G is the stage succeeds the 4G, LTE VMAX, 3G, AMTS and 2G, GSM systems. 5G targets to perform the high data rate, reduced latency, energy saving, cost reduction, higher system capacity, and massive device connectivity. The two phases of 5G, first one will be complete by March 2019, second one is expected to complete at March 2020 for submission to the ITU, International Telecommunication Union, as a candidate in 2020 technology. The ITU IMT 2020 provides speed up to 20 gigabits per second. It has been demonstrated with millimeter waves of 15 GHz and higher frequency. 3GPP standard includes any network using new radio software. 5G new radio can access at lower frequencies from 600 MHz to 6 GHz. Speed in the lower frequencies are only modest higher than 4G systems, estimated at 15% to 50% faster. LiFi is a wireless technology which uses light-emitting diodes, LEDs, for data transmission, whereas Wi-Fi uses radio frequencies for data transmission. LiFi is the short form of light fidelity. The term LiFi was first used by Harold Haas, professor in Edinburgh University. The computer scientists achieved speeds of 224 Gbps in the lab, and research is going on. The biggest revolution in the internet world is going to happen. Wi-Fi stands for Wireless Fidelity. It is a wireless network technology that permits computers and other devices to be connected to every other into a local area network and to the net without wires and cables. Wi-Fi is additionally stated as Wireless Local Area Network, and 802.11 is the technical code for the protocol. It provides mobility. It provides connection to Internet. Flexibility of LAN. Ensures connectivity. Low cost, high benefits. RFID is a technology designed to locate objects using radio signals. RFID uses radio waves to read and capture information stored on a tag attached to an object. The tag can be read from several feet away and does not need to be in direct line of sight of the reader to be tracked. RFID is made up of two parts, a reader and a tag or a label. RFID tags are installed with a transmitter and receiver. There are two types of RFID tags, active RFID and passive RFID systems. RFID is a game changer in how we track and manage inventory. Imagine a tiny chip, no bigger than a grain of rice, that can store data and communicate wirelessly. These chips are embedded in products, allowing businesses to monitor their stock in real time. No more manual scanning or lost items. RFID technology automates the process, boosting efficiency and accuracy. When you walk into a store, RFID tags can help retailers know exactly what's on the shelves and what needs restocking. This not only saves time, but also reduces waste. In logistics, RFID ensures that packages are tracked throughout their journey, minimizing delays and errors. It's not just retail. From healthcare, where RFID helps track medical equipment, to agriculture, where it monitors livestock, the applications are endless. RFID is revolutionizing industries, making our lives smoother and more organized. It's like having a personal assistant for your belongings, ensuring everything is exactly where it should be. The OSI model, or Open System Interconnection Model, was founded in the year 1934. It provides a general framework that enables network protocols, software, and systems to be developed based on a general set of guidelines. It describes the standards for intercomputer communication. The first layer is the physical layer, which defines the electrical and physical specifications for devices. The second layer is the data link layer, which guarantees that the data transmitted is free of errors. This layer includes simple protocols like 802.3 for Ethernet and 802.11 for Wi-Fi. The third layer is the network layer, which determines the path of the data packets and is responsible for routing data packets using IP addressing. The fourth layer is the transport layer, which guarantees the successful transportation of data and includes error-checking operations. The fifth layer is the session layer, which identifies the established system session between different network entities and controls dialogues between computers. For instance, while accessing a system remotely, a session is created between your computer and the remote system. The sixth layer is the presentation layer, which translates data to the next layer and prepares the data for the application layer. Encryption and decryption protocols occur in this layer, such as Secure Socket Layer or SSL. Finally, the seventh layer is the application layer, which acts as the user interface platform comprising software within the system. TCP/IP Transmission Control Protocol Internet Protocol. TCP/IP is a set of protocols which governs communications among all computers on the Internet. TCP/IP protocol tells how information should be packaged, sent, and received, as well as how to get to its destination. TCP/IP is a combination of two protocols, Transmission Control Protocol, TCP, and Internet Protocol, IP. The Internet Protocol typically specifies the logistics of the packets that are sent out over networks. It specifies the packets which have to go, where to go, and how to get there. The Transmission Control Protocol is accountable for guaranteeing the trustworthy transmission of data. It checks if any packet is not transmitted and submits it again. Frequent TCP/IP protocols include HTTP, which is used between a web client and a web server and guarantees non-secure data transmissions, and HTTPS, which is used between a web client and a web server to ensure secure data transmissions. FTP is used between computers for sending and receiving files. The address for any website is not as easy to remember. Domain names are used instead. For example, 216.58.216.164 is one of the IP addresses for Google, and google.com is the domain name. There are 4 total layers of TCP/IP protocol. The network access layer is concerned with building packets. The Internet layer describes how packets are to be delivered. The transport layer ensures the proper transmission of data. The application layer includes application network processes such as File Transfer Protocol, FTP, Hypertext Transfer Protocol, HTTP, and Simple Mail Transfer Protocol, SMTP. Other network protocols, other than OSI and TCP/IP, are simply known as other network protocols which implement security over network communication, including HTTPS, SSL, and SFTP. Other networks similarly classified in the network layer are IP, ARP, ICMP, IGMP. At the transport layer are TCP, UDP, and at the application layer are HTTP, FTP, Telnet, SMTP, and DNS. Several networks, small and big all over the world, are connected together to form a global network called the Internet. It is a website used by organizations to provide a place where employees can access company-related information. It is a private network using Internet technology to share part of business information with suppliers, partners, and customers. Advanced Research Projects Agency Network. Transmission Control Protocol, Internet Protocol. Wireless Fidelity. Radio Frequency Identification. Open System Interconnection. Hypertext Transfer Protocol. Hypertext Transfer Protocol Secure. File Transfer Protocol. Simple Mail Transfer Protocol. User Datagram Protocol. Domain Name System.
I just want to take a moment to express my gratitude for your support. Every time you watch my videos, it motivates me to create even more content that you love. If you find value in what I share, please consider liking and sharing. It really helps spread the word and brings more amazing people into our community. Your engagement not only fuels my passion, but also helps me improve and explore new ideas. So, if something resonates with you, don't hesitate to hit that like button and share it with your friends. Together, we can make this channel a vibrant space for everyone. Thank you for being a part of this journey.